All right, in this lesson, we're going to be learning about some identities, trig identities, and these are ones that you definitely need to commit to memory because you will be using these at other times besides just this test. All right, the first set of identities is what's referred to as the reciprocal identities. This actually goes back to what I had talked about in the previous lesson. About when we were making the trig ratios, like for instance, sine was y over r. And then if you remember, I pointed out to you that cosecant was actually the reciprocal. It was r over y. So you can tell that the way these are written, it has these matched up based on those reciprocals. So if you know, let's say that you know the value of cosecant, then you could do 1 divided by that value, and then that would give you the reciprocal, which would be your sine value. So cosine would be 1 over secant, tangent would be 1 over cotangent, and these three are just the reverse of these. So you have cosecant would be equal to 1 over sine, secant would be equal to 1 over cosine, and cotangent would be equal to 1 over tangent. So like I said, that's just going back to how we saw the identities matched up before. All right, next we have at the top what's called your ratio identities. Okay, so for your ratio identity, you have tangent theta is equal to sine theta divided by cosine theta. So if you know your trig value for sine and cosine, then you could do your sine value divided by your cosine value, and that would give you your tangent value. Now, since tangent and cotangent are reciprocals of each other, then that's why you're seeing these being reciprocal. So really, if you can remember this one's just the reciprocal of it. Okay? So we'll use that, what's called your ratio identities. All right, next we have Pythagorean identities, and let's talk about these here at the top first. I'll just cover this one at the bottom for just a minute. All right, the first one we're going to look at is sine squared plus cosine squared equal 1. Again, that's called a Pythagorean identity. Now, the 4 that I have listed down the side over here, these 4 actually all come from this. So if you can remember this one, you can just do a little bit of algebra to come up with these. Like for instance, the first one, all I've done is just simply gotten sine squared on one side by itself. So if I want sine squared by itself, that means since this is adding cosine squared, I would just need to subtract it on the other side. So 1 minus cosine squared, so would be this one. So then if I want cosine squared by itself, then all I have to do is subtract the sine squared and I get this one. Now these two, you can say come from these two. Okay, so compare these two. If I want, where this has sine squared by itself, if I want just sine, that just simply means that I take square root of both sides. So if I take the square root of sine squared, I get sine. And then I take the square root of the 1 minus cosine squared. Of course, you don't forget your plus minus. So this one then would come from this one just by simply taking square root of both sides. So it's not really that you need to memorize these as much as just know how to get these from this if need be. And that way you have that much less memorization of identities that you have to do. Now you also have these two that are also called your Pythagorean identities. So go ahead and write those down. And those actually come from the one at the top also. And you can go through some steps with this one to come up with this one, and same thing to come up with this one. But usually it's just easier on these just to go ahead and memorize those. Okay, so using these identities on a few problems, and these are some very basic ones. All right, so here you're told to use the reciprocal identities. All right, so you're told that cosine is equal to -7/9, and you're asked to find secant. Now, if you're told to use the reciprocal identity, I know that secant is equal to 1 over cosine. So that means I would have 1 divided by -7/9. So say I'm replacing my cosine theta with the -7/9 since those are equivalent to each other, okay? Then if you were to simplify this, if you do 1 divided by -7/9, then you're going to get a -9/7. Now your negative sign, you can keep it there with the 7 if you want to, or you can simply move it out front. Now, is it necessary, to physically go through these steps? No, not really, because just knowing these are reciprocals of each other, it's just as simple as taking this and just flipping it. But this would show you how that identity works. There's going to be some things that we're going to do, though, in which you have to know this. You have to know exactly how to write that secant theta is equal to 1 over cosine theta. So still make sure that you know how to write that identity, even though to work this problem, it's just a matter of just flipping a fraction. Okay, on this one, we're told to use the ratio identity, and we're trying to find cotangent. All right, your ratio identity for cotangent. Now make sure you are picking the right one. You do want the ratio, and the ratio is the cosine over sine. Okay, so cosine is 15/17. Sine is -8/17. Now, there's different ways of simplifying this, but I want to show you something that's quick and easy that I'll end up using a lot. You can always start or simplify this by multiplying the ones on the what I say the outsides. That means the very top and the very bottom, okay? Now, I'm not going to physically multiply 15 times 17. I'm just going to write it over here as 15 times 17, but you are multiplying those two together, okay? Then come back and multiply the two that are in the middle. So that means I'll have a -8 times 17. Now, the reason why I didn't bother physically multiplying those numbers is because I knew what was fixing to happen. I can cancel out those 17s, so therefore my answer is -15/8. Now, if you physically multiply those numbers, then you're going to end up, with a large numerator and denominator that you'll have to reduce, and it'll end up reducing down to be the same thing that I got there. Okay. Next. All right, so this one's not actually using an identity. It's basically just making sure you understand some notation. You are given that cosecant theta is equal to -2 divided by square root 3, and you're asked about what cosine squared theta. Now, this is just to the second power, but when it comes to raising trig functions to a power, you will always see that power written in between. If it were to ever be written, you're used to your exponent being here at the end, then you would have to have this in parentheses to the second power. If you don't put it in parentheses, the square is only on your theta, only on your angle, which is something totally different than the fact of your trig function being squared, okay? So if we want to know cosecant squared, then you just simply take the value for cosecant that you know and you square that value. So you square your numerator, square your denominator. So your answer is 4/3.